Greeting to all examiners, my name is Wong Ki-Siang with matric number 71964, and I have three group members who are Eric, Cornelius, and Emmanuel. We are from Group 11 Yao-Ji Engineering Firm. We are going to present our design of plant oil harvester. In this presentation, there are 5 main outlines, which are introduction, problem statements, ends and objective, methodology, and conclusion.
My name is Eric Wong with matric number 69610, and today we are going to introduce our product, which is the motorized punk harvester in use of the palm oil. Palm oil is regarded as one of the most important national commodities in Malaysia. At RM 52.3 billion export value in 2020, the commodity contributes about 73% of the agriculture exports in that year, which is making Malaysia one of the largest palm oil exporter in the world.
There are 3 problem statements in this project, which are raw efficiency and productivity of the palm oil cutter, fatigue rate of workers, and safety issues. Next, we go to objective. There are 3 objectives here. The first one is to improve the palm oil harvesting machine that can effectively gather the fresh fruit branch of palm oil. The second one is to design a reliable design that can consistently harvest the weight of a real fruit. The third one is to develop a user-friendly design to increase worker productivity.
For the professional ethics, we have done mainly 3 parts on the society, legality, and also the health and safety. For the motorized punk harvester design, we have done the design on the customer requirement, and we have also done the conceptual design, detailed component and failure analysis, material selection, cost-benefit analysis, engineering drawings and modeling, and also the simulation on the static and dynamic analysis, and also the thermodynamics and fluids. We have also fabricated the prototype and proposed a detailed manufacturing system as well. For the legality, we have compared our product to the existing design in the My IPO in aspect of overall design, blade structure, and also the power supply to make sure that it does not conflict with the Patents Act 1983. For the health and safety, we have done the risk assessment, the safety control measures, noise risk evaluation, and also the vibration emission evaluation on our product as well. Our product design consists of a few main components, which is the cutting blades with a saw and chisel shape, and also a motor and gearbox. And there's also an emergency buzzer attached on the casing to alert the user. Besides, there is 2 handles on the pole, and the power switch is also on the pole to open the motorized pump harvester. And there's also a LCD screen on the handle as well to indicate the battery level. And lastly, there's a lithium-ion battery at the bottom of the pole as well. The parts that I would like to emphasize in our product highlights is our product is cheap. Also, our product is also simple and easy to use. Plus, our product is user-friendly as we are using lithium battery that's rechargeable. And also, our product is able to increase the productivity. And lastly, is our product is safe to use and also comfortable to use. Our motorized pump harvester is actually having a very simple working mechanism where the motor will supply the power to the bevel gear, which converts the rotational motion into the linear motion by using a mechanism called Scott-Young mechanism as shown in the video, which will drive the blade to move and to achieve the cutting operation. We have done our simulation on the static analysis using the ANSYS and also the Fusion 360 software, and we've mainly done our static analysis on nut connection with the blade and also the ball deflection. For the ball in nut connection with the blade, we can analyze that the maximum deformation occurs on the top part of the blade with a maximum value of 1.04 times 10 power negative 5 millimeter. That is very minor deformation. Besides that, we can also observe that the safety factor in terms of equivalent stress is also having a minimum safety factor of 1, and most of the area occurs a green zone, which indicates that the ball and nut is able to withstand the working load that is applied from the Z direction downwards to the connection plate with a value of 250 newtons. For the pole deflection, with a condition as shown in the figure, with a actual working load of 200 newton and also an external force of 10 newton, the pole is having a maximum deformation of 0.64 millimeter, which is very minor deflection towards the structure, and it will not cause a mechanical structural failure on the pole. On the other hand, we have also done our dynamic analysis on the model analysis and also the random variation analysis. Model analysis helps us to identify the frequencies of the structure and the corresponding mode shapes so that we can observe obvious deformation in mode 4, and also the highest deformation occurs in mode 5 as well. Besides that, we have also done our random vibration analysis, and it is used to calculate the system structural response to a spectrum of random excitation, and the non-deterministic log. Both 1 sigma and 2 sigma condition has the highest deformation that focus on the black part. This suggests that we may need to add more reinforcement and also connection to the upper part of the motorized pump harvester to ensure less deformation due to the vibration effects.
Hi, I'm Emmanuel Connery, the metric number 72211, and I will be in charge for the mechatronics section. There are two systems will be integrated on the prototype, which is heat sensing unit and battery level indicator. First of all, we are going to take a look on the battery that our group has selected, which is the Bosch 18-volt lithium-ion battery. The reason we choose this battery is because it has a high battery capacity and sufficient voltage to run the motor, which we introduce in the next slide. Next, this is the motor selected for the prototype. Previous calculation indicate that the motor deliver enough power to perform cutting provided by the torque given. It also has a sustainable power rating, which will be energy efficient in terms of performance for cutting. The material for the motor is metal, which provides durability and are sustainable to resist the heat generated during work. Now, I will jump right to the heat sensoring unit. These are the description on the flow of work performed by the heat sensoring unit. The placement for the heat sensor will be inside the casing near the motor to monitor the heat generated during the operation. So, the first step is the heat sensoring. The heat sensor will be placed near the motor component, as moving component will heat up easily due to friction. So a suitable sensor will be selected which suits the requirement. This will be shown in the selection criteria. Next, we have to display the level of heat. So by using LED lights, the user will be able to read the level of temperature from the display unit. Next is the overheat warning. So a buzzer is installed to warn user when overheating is happened. So the recommended action taken for the user is to manually switch it off. Therefore, we select this sensor, the TMP36, for this heat sensoring unit, as it requires low voltage and has decent precision. It also has the accuracy of 1 degree, ranging around 1 degree Celsius at 25 degree temperature, and around 2 degrees Celsius over 40 degrees Celsius up to 125 degrees Celsius, which meet our requirement. The cost is also around 10 ringgit, which achieve the costing requirement. These are the selection criteria, which is for the sensor. The temperature range is between 20 to 120 degrees Celsius, as stated from the thermodynamics part. We also need a fast response time for the user to take action faster and to minimize damage on the motor and gear. Next, the power consumption for the sensor must be low, because we are using battery and the capacity is very limited for the device to run a long hour. We need a low power consumption for the sensor. Lastly, the cost. Based on the survey conducted from any shopping website, most of the sensors are ranging around 20 ringgit. So therefore, the sensor must be below 20 ringgit and below. Lastly, I will simulate the heat sensoring unit. So as I increase the temperature here, there are stages where the LED will light up, and eventually if I put it on max, all the LED will light up and the buzzer will ring. Lastly, I will simulate the heat sensing unit. So, as I increase, the next section of mechatronics will be the battery level indicator. Firstly, I want to introduce the component that will be used for this unit. Firstly, the LED indicator, which is composed of LED lights of multiple color. It is arranged in such way that it helps to indicate the battery level. Next is the potentiometer. The potentiometer will be control the voltage that is running to the device for voltage regulation. And lastly, the LCD panel. This panel will display the voltage that is running throughout the system. The workflow process for the battery level indicator is described from this coding sequence, which is one is to display the voltage on the LCD screen. Next is to display the logically scaled portion input voltage range on the LED bar graph. And thirdly, if the battery capacity is full, it will flash red and green on the LED bar. The simulation for the battery indicator will be displayed by this video. The battery is replaced by a power supply unit, and the potentiometer will be adjusted for voltage regulation. So I will show how the LED respond to the battery level.
Hello, my name is Cornelius Bong with metric number 7216868. So this is the thermal part of our project. So firstly, we calculate the heat produced by the DC motor, bevel gear, and the bearing, which is the component inside the motor casing. We use the formula of efficiency to produce the heat loss, which is also the heat produced by the DC motor, as shown in the figure. The total heat produced is 8.2918 watt. Next is the thermal analysis of our design. We assume the motor casing of our design as a cube that have 6 walls, as shown in the figure. The energy balance for the thermal analysis is heat in equal to heat out. Therefore, heat in is the heat produced by the component, and therefore the heat out is 8.2918 watt. So the figure below show the control volume of the analysis. The figure show the heat transfer model for the thermal analysis of our design. So this formula is used to calculate the temperature at the component inside the motor casing, which denoted by T infinity 1, and also to calculate the temperature of the inner wall of the motor casing, which is denoted by T2, and the temperature of the outer wall of the motor casing, which is denoted by T3.
For the thermal analysis, the maximum temperature at the component inside the motor casing calculated is 115 by 98 Celsius. Since the maximum temperature inside the motor casings is very high, an optimization for ventilation is needed to release the heat generated by the DC motor. The initial design of the motor casing has only one ventilation window, which is located at the front of the motor casing. This design of ventilation is significant to release the heat from the motor casing. To improve the ventilation, the optimization is adding 2 more ventilation windows at the both sides of the motor casing. This can be described by the natural ventilation. Natural ventilation in a motor casing refers to the use of natural forces such as wind and thermal balances to circulate air around the motor and dissipate heat. This can be achieved through the use of more windows placed strategically on the motor casing. These openings can be decided to take advantage of natural airflow patterns to enhance cooling of the motor and prevent overheating. The manufacturing workflow starts from supplier, raw materials, manufacturing process, quality assurance, packing, storage, and shipping. LG engineering firm has in partnership with other supplier company. The raw materials and components that supply from the supplier are listed here. The manufacturing process involved in LG engineering firm are fabrication, manufacture, and assembly. The manufacturing processes has been classified into two categories of production system which used in the production line. The two categories of production systems are work machine system and automate systems. Machine system is defined as a worker who perform one or more tasks by operating power equipment. The manufacturing processes that using work machine system are finishing process of motor casing, grinding process, fastening lithium battery, installation of DC motor with gearset and sensor. Automated system is defined as a process performed by a machine without direct participation of humans. The manufacturing processes that using this system are cutting process, welding process, turning process, installation of tunable pole with seeker and packaging. Manufacturing is the process of transforming raw materials into complete product with the use of equipment, raw material, and tools. Materials like aluminum sheet and high carbon steel plate are the example of raw materials that are transformed into complete product of motor casing and seeker. The manufacturing processes involved in Yaoju engineering firm are cutting process, sliding process, welding process, grinding process, and turning process. The cutting process is used to fabricate the motor casing and seeker by using grinder. For motor casing, the fabrication starts from raw material, which is aluminum plate. After all the parts are done for fabrication, they will be joined by using welding process. The type of welding process used is called arc welding. The surface of the welding pipe need to be sanding by using sanding machine. The purpose of this process is to make sure the surface of the motor casing is smooth and safe. The fabrication of seeker is also using conventional cutting process by using grinder. Grinder is used to cut out the shape of seeker from the high carbon steel plate. After cutting out the shape of seeker, the next process is grinding process. The grinding process is to grind the edge of the seeker and make it become a sharp plate. In Yaoju engineering firm, turning process is used to manufacture the changeable stainless steel pole. Turning process creating the thread on the stainless steel hollow pipe which is supplied by the supplier. Assembly is the process of bringing together various parts or components to create a finished product. In Yaoju engineering firm's manufacturing factory, the assembly process may involve a combination of manual labor or automated equipment. There are several steps involved in the assembly process, which are preparation, sub-assembly, and final assembly. Quality assurance is an ongoing process that involves a range of activities and processes designed to identify and prevent defects in the product or services being provided. Besides that, QC is the process of ensuring that a product meets certain standard of quality before it is released for sale or distribution. Yaoju engineering firm also implement ISO 9001 standard to produce a good quality of palm oil cutter. The plant is classified into three main stations, which are manufacturing station, assembly station, and packing station. The table below shows the estimated time and number of workers in manufacturing station, and the figure beside is the manufacturing department layout. The table shown at the left is the estimated time and number of workers in assembly department, and the figure shown at the right is the assembly department layout. The table shown at the left is the estimated time and number of workers assigned at the packing and inspection department, and the figure at the right is the packing and inspection department layout. This is the production rate of the production line, which can produce 3,150 units per year. The material handling used in Yaoju engineering firm are Yaoju handcraft, forklift, and roller conveyor.
This is the economy part for our project. So this is the variable cost that include to produce our harvester, which include all the components that we need to produce the harvester. Then the total cost of component that needed to produce the harvester is 893 ringgit and 57 cents. For labor, the total cost per unit product is 229 ringgit and 35 cents, and the monthly cost for rental, bill, lesson and permit, and insurance is 92 ringgit and 67 cents per unit of the harvester. Total cost for machine and equipment is 708 ringgit and 88 cents, but we assume that the machine and equipment is last for 7 years. In 7 years, we are able to produce 22,050 units of harvester. Therefore, the cost of machine and equipment per unit products is 4 cents. The total fixed cost is 322 ringgit and 6 cents. The total cost is 1,250 ringgit and 63 cents. Therefore, we decide to sell the harvester with price 1,590 ringgit per unit. To achieve the break-even point, we need to sell 10,197 units of the harvester.
In conclusion, Teams is able to achieve the objective of the project, in which one of them is able to come out with an analysis that is meaningful and consistent. Besides that, final product design with well functionality is come out with the detailed analysis on static, dynamic, mechatronic, manufacturing, and economy.